The sampling technique described for the current population survey was way more complicated than anything that I would expect you to be able to produce here. But I do want us to look a little bit closer at this idea of stratified random sampling. So ultimately what you do for stratified random sampling is that you divide your sampling frame into distinct groups. We're going to call these strata. You choose individuals to be in each strata based on some shared similar characteristic. So this would be things like gender. You would have males and females as the two strata. Or maybe age, where you would have young adults, middle-aged adults, older adults. Each of those would be a strata. They have something in common. Then within each of these stratum, which is the singular there, you take a simple random sample. And then each of these simple random samples collectively creates the entire sample. So you could look at this example with a large university of 30,000 students, 3,000 are graduate students. So if you were taking a simple random sample of 500 students, that would give every student the same chance of being in the sample. There were 500 students that will be chosen out of the 30,000 students total, and so each student has a 1 in 60 chance of being in the study. But perhaps we want to make sure that we represent both undergraduate and graduate students. So we could do a stratification technique where we ensured that we took 200 graduate students and 300 undergraduate students. So what you could do is you could label the graduate students 1 to 3,000 and then take the table and select which of those students are going to be in the sample. You will have to take 4 numbers at a time since you're going from 0001 to 3,000. Now you can do the same thing for undergraduates, label them 00001 to 27,000, and then get a sample of 300 students. So you're going to have 200 randomly selected from graduate students, 300 randomly selected from undergraduate students. But by doing this, you do note that graduate students have a higher chance of being chosen for the study. You're picking 200 out of 3,000, so they have a 1 in 15 chance to be chosen. Whereas the undergraduates, there are going to be 300 in the study out of 27,000, and so they each have a 1 in 90 chance to be chosen. So this would not be a simple random sample. However, having both undergraduate and graduate students in the survey would be helpful for the data to reflect the entire student body. Now, we do recognize that with these 2 simple random samples that we could estimate the opinions of the 2 groups separately. So using that margin of error formula from our previous chapter, 1 over the square root of 200 would give us a 7% margin of error for graduate students. But with the sample size of 300 for undergraduate students, our margin of error will be 1 divided by the square root of 300, which is a 5.8% margin of error. And if this was being done by a professional statistician, they would adjust for the overrepresentation of graduate students in the final results. And so with some complicated techniques, they can even out the fact that graduate students were more likely to be in the survey.